Good morning, everyone. Thank you for coming to our webinar that we're hosting today. Everyone should be slowly filtering in, but we're going to get started. We've got a lot of information to go through. So today you've got me. If you haven't attended any of our webinars, my name is Thomas White. I'm our senior engineer out of the Brisbane office in the Australian team. With me is Dylan Woodham, who is one of our electrical engineers who works in our technical services team. What we're going to be going through today is a little bit of a spotlight on what we've been doing at EA and what we are innovating and pushing forward towards the future. For those of you who haven't learned too much about EA and our partial discharge products, all of the development is done in-house, and our development team has been putting in some really good work pushing new innovation and new features, and we wanted to take a bit of time to show them off and kind of get them out and make it sure everyone is understanding what you can now do with the device. So a little bit about EA, and it very much relates back to our PD testing products and our development. We're not a new company. We've been around for nearly 60 years with our head office over in the UK, in a place called Capenhurst, and then we've got 5 other global offices, including the Brisbane office in Australia, where we're based. We've been doing this for a long time, and we've been really focused on working with people to develop products that are applicable in the real world. And we're going to talk about that a lot today. So this is us, worldwide view. What we're going to go through today is a little bit about looking at not only what we are newly releasing, but we're also going to talk a little bit about what we have been making. What are the new releases that you may have missed if you haven't been doing regular trainings or if you haven't been really keeping up to date with the device? If you do regular trainings with us, one of the things you may notice is the device is doing more and more functionality to the point where some people are having to extend it from a 1-day training to a 1.5 or even a 2-day training. Now that we've put so many more features in and so many more test methods, we're really having to combine it because the kit can do so much more than it used to do. So I'm going to cover that, and then we're going to bring in Dylan, who's going to talk about what are we doing at the moment? What are these new features we've been talking about? What have we been teasing? And how can you best apply them? I'm going to come back and then talk about what are we looking forward to in the future development of Plus 2. And there's some really fun bits of kit that I want to have a good chance to talk to everyone about. So let's look at the history. The UltraTEV Plus² specifically has been around for quite a while now. It is a device that we've done a lot of improvement on. Where I'm going to talk is starting in April 2022, and that was our last really big step change for the UltraTEV Plus² device. It's when we released a huge amount of new functionality, and then we've been slowly adding to it ever since. Before that, we introduced sensors like the UltraTEV locator, the UHF and the directional antenna, and the new HFCT. Since we've added a lot more. I'm not going to go through every single feature, but I'd really like a chance to sit there and talk to you about what are the greatest hits. So what have you missed? If you haven't been fully keeping up to date, this is what we've been working on. So one of the really big ones that were released in version 4.0 was managed surveys and the full cloud integration of the Plus². So this allows the Plus² to hook up with a cloud server. It allows you to plan all of your surveys, all of your substations, all of your guided modes and workflows in the cloud, download that to the device automatically, assign work orders and assign jobs. Then the person in the field can go out, select that workflow, get stepped through it individually based on what tests are needed. When they're done, that data automatically gets collated, sent back up to the cloud where you can analyze it. It gets automatically trended and put against previous records. It was a full step change of this device, taking it from a handheld point and shoot towards a fully integrated bit of kit. From there, we started to move on with things like the wireless days reference. And a lot of this has been driven by client feedback and real world data. Again, the managed surveys was born from people talking to us about they were having trouble with trending data. How do they manage these large data sets when you're doing a large amount of testing? How do you keep all this in a way? So that solves that problem. One of the problems we also received is with the phase lock. Clients were having more and more issues with substations moving towards LED lights, doing more testing in RMUs and outdoor yards where they were just really struggling to achieve that phase lock. Without the phase lock, you get less consistent data, which makes your analysis so much more difficult. So that's why we released the wireless phase reference accessory, that small blue box you can see on the right. And what it does is captures that phase lock remotely and Wi-Fi's it to the +2. For me, as a person in the field doing this testing, this was a game changer in terms of reliability of testing. It allows you to use all the same methods as the +2 does regularly. However, it also introduces the Rogowski coil, where you can put it around a HV or LV cable and get the phase reference from that way. But most importantly, you can just plug it into a 240-volt power supply, and it works very seamlessly, ensures accuracy of data, and this was a big one. From there, we brought out version 4.4. I'm starting to skip a little bit here, but one of the big ones that we receive a lot of feedback in is with IT and security, the traditional way of updating the +2, where you put an update file on the SD card, you put that in, run the update, is becoming harder and harder. We've been having more and more difficulty getting those update files to people and having them be able to download it to the device. So the over-the-air updates fixes that. So now with the device, you can go on, hook it onto a Wi-Fi, then you click a few buttons and it will automatically download the update and it will install it automatically. This allows people to do it much more freely, then you're not having to rely on sending the device back to us. The reality is, nearly every device that comes back to us for calibration each year, we're doing updates on manually. So hopefully this will give people a bit more freedom in order to get those updates working. During this update, we also did a lot of just small quality of life changes, a lot of updates on the screenshots and different capabilities, making sure that you truly can record your data in the way that you're wanting to. And we also did a lot of updates on the UHF testing, the spectrum analysis. Once we released and moved from the old PD Hawk to the UHF accessory for the +2, we started to do a lot more in-depth analysis in the UHF. So what we found is that being able to overlay multiple spectrum sweeps on top of each other gave you a lot of detailed analysis that you could then go and find more PD defects. So we improved that and added in as native operation. Then we go on to one of the big ones, and honestly one of my favorites. 4.5, we released the VPIS accessory. So a new accessory that plugs into the side of the +2 and allows you to test for PD using the VPIS or VDIS testing points in the gear. And this has been very, very revolutionary. It allows you a standardized test point. It allows you to test each individual phase separately, red, white, and blue to earth. And you can see a really in-depth and granular display of what is going on within your switchgear. Works really well for main switchboards and works really well for RMUs as well. We've got a lot of good data of this and we're seeing a lot of really good feedback, and it's being quite sensitive. We also did a lot of work on the optimization of the +2. One of the big problems you have is once you start to gather more and more data, and especially once we start what Dylan's going to be talking about, we needed to make sure we were doing it as optimally as possible. We weren't slowing the device down, we weren't having issues. As part of that, we also put in the ability to recover surveys. If something odd does happen, if the device runs out of batteries, you can go back and you can recover any lost data in the device naturally. And that's really good for when something goes wrong, not that it does often. We also are on a continuous grind to update and keep all of the switchgear manufacturers and models fully up to date. So again, If you do find any that aren't there or any that aren't working, or you've got a bunch of switchgear which isn't in our device, if you let us know, we will strive to get that included in future updates. We then move on to making the best use of our data. And 4.8 was really the groundwork for what Dylan is going to be talking about with our current release. We started to make a lot of good use of the data that we are capturing. If you ever really delved into the raw data that the Plus² captures, we've been capturing a lot of extra data for a long time and doing a lot of analysis on it in the background, and we've started to really make good use of it. So one of the things we added was simple filtering on pulse width and rise time for all for your TEV and cable PD measurements. So on the right hand side here, you can see something very simple. So you've got a PD phase plot with multiple sources of PD with a contact noise source intermingled into it. And then just by doing some simple filtering on the waveforms of all of those PD signals, I can almost immediately start to filter out that contact type noise and leave just the PD signals behind. On top of that, we start to introduce some long asked for things such as overlaying the sine wave, which you can see here, as well as you can also put a 3-phase sine wave if you want. You can also phase shift all of the data to make your plots a little bit clearer, so nothing's going over that 0 to 360 axis. It's just a lot of small quality of life activity that people have been asking for a long time. Something else that the team in the UK and the dev team have been working on is updating our help screens. So no longer are they just raw chunks of text that you can go and you can read. Now, if you go on the Plus² to the help screen, it'll give you a QR code, which directs us back to that cloud platform where we've got a whole bunch of little videos or webinars that can step you through individually. If you've been on LinkedIn recently, you may have seen Brad Monaghan demoing some of the different features, and we're endeavoring to get them added to it as well, just so you've got a guide on the simple use of the device. One of the other ones that came from customer requests was the ability to input in custom HFCT features into the Plus². So obviously the device is primarily made to work with our HFCTs. However, a lot of clients have had CTs installed for different reasons over the years, and they were wanting to use it with those CTs. And whilst it has always worked, the scales and the amplitudes are a little bit off based on the different CT specs. So now if you know the specifications of your HFCTs that you've got installed, you can program that into the device and you can get accurate, reliable data repeated continuously. So that's just a bit of a summary of where we've been. Since 2022, we've done 10 good firmware updates. Out of that, there's been 55 new features added and functionality, all developed in-house by the dev team. And they've done some really good work at looking at feedback from the field and making sure that it will work and implementing it into the kit. We've added the full web integration. And we've developed 5 new accessories: the VPIS accessory, the wireless phase reference, the HFCT 100, in case you haven't seen it, it's a bigger HFCT for different cable sizes. And we've also introduced 2 new UHF accessories in the GIS band sensor, which is used for GIS switchgear, and the internal UHF sensor in case you ever want something installed permanently within chambers. But the biggest thing is the continuous optimization and improvements. And one of the things I do have to really thank a lot of the clients we work with is you are really good at giving real world feedback and case studies where things aren't working for you. And I think one of the things that we pride ourselves on a lot, and the dev team is really focused on, is taking that feedback, making sure that it is applicable in a worldwide stance, but then integrated into the device. Without people letting us know what is or isn't working, it's quite difficult to make this move forward. On top of that, they've always tried to have a continuous development and a focus looking forward. So this is what we've currently got. A lot of these things are new, so we've got the VPIS, the band sensor, which are quite new accessories. We've got the directional antenna, the HFCT, and the locator, all things like that, which have been around for quite a while. And on the bottom left there, you can see a bit of a hint of what is coming out next. But before we get to that, I'm going to pass over to Dylan, who's going to talk about what we've recently released and what you can look forward to in our latest updates.
Thanks for that, Thomas. Hi, everyone. As some of you will know, at EA Technology, we've released our next big update to the UltraTEV Plus². We've added a lot of new features that will aid both in-field testers and those who are analyzing data back in the office. Over-the-air can be used to download firmware 5.0, which is the latest firmware. I know a lot of you have already have a Substation 360 account. For those of you who do, you can log on to your Substation account and download the update there. Otherwise, you'll be able to navigate to the QR code on your UltraTEV Plus², and that will take you to create a Substation account. We'll also include a QR code later in the session, and you can access it there. The new firmware and its new features are all free to use with the UltraTEV Plus device. The 4 new features we'll be covering in this section are the increasing asset classes, AI, integrated into the device, TF mapping analysis, and cable PD location. The first topic we're going to be covering is the new asset classes. Traditionally, the UltraTEV Plus² has been configured with a single layout specifically designed for the metal-clad switchgear, requiring quite a bit of imagination when scanning other HV assets, such as transformers or outdoor yards. We know that some of you on the call have mentioned an interest in different asset layouts and component type variations. We've listened to that feedback and introduced a new initial classification step in the workflow. This allows you to select a broader range of HV asset types right at the start of the testing process.
So just getting the Q&A up so I can keep track.
So what this means for you is that all your recorded data can now be mapped directly to the type of asset that you're testing and to the component that makes sense. There are now 5 asset type categories. These categories are the metal-clad switchgear default, which is the version that we're all used to, the transformer, the outdoor switchyard, the metal-clad switchgear simple, which is just a simpler version where you can scan the front, rear, side, just less information, and the GIS switchgear, which is a little less popular here. I'll now walk you through what that looks like in the software of the device. So here on the left side in this picture, we've got the asset types. You can see the new categories in here. Up in the top right, we've got the metal-clad switchgear default, which we're probably all used to seeing by now. But we've got the asset name, the panel number, the component, and the switch position. Down below is the new feature, the outdoor switchyard. It's one of the new asset types. You'll notice that some of the menu options have changed. We now have asset name, line number, component, and substation. This just makes a lot more sense in a yard where you'll have multiple lines with multiple components that, such as the transformer, the air brake switch, lightning arrestor, a bit more specific to what you're testing. So once again, this is the metal-clad switchgear, the default. Right here, you've got the CT chamber selected, but we've got various components in here, the cable box, CT chamber, VT chamber, and upper bus bars. This is the menu for the outdoor switchyard. We've got a new component menu with new assets, depending on what you will find in a switchyard, outdoor switchyard. We've got the incomer cable, overhead switch, circuit breaker, voltage transformer, and current transformer. And so now you'll see that the switch position, is blinked out, and you now have a sublocation. And this directly relates to what part of that component you were testing. So here we can see the conductor connection, the insulator bushing. The sublocation menu will change depending on what the component is selected. For example, if it's a voltage transformer, there'll be a tank, whereas a lightning arrestor would not. So for all of you who have experience with our managed server platform, which Thomas mentioned, you'll notice a few things have changed. We are now able to switch between each asset via all the tabs with their own data recordings and all captured within a single survey file. Our workflow generator has also received an uplift, allowing all new asset types and menus to be configured in advance and save time while testing HV assets on site. Here's a peek into the new managed survey interface once your data has been uploaded. You can see some panels up above which weren't previously here. So we've got the bus rollers, the indoor, outdoor, you got a transformer here, and all their categories are down below that. So you got the outdoor switchgear, switchyard, switchgear, transformer. And over here, we've got all the panels, which you've seen before. We've got image, panel number, and where all these tests are being conducted. So you got some TEV tests and some VPIS tests. On the right-hand side, we've selected the outdoor switchyard. You can see that all the panel, the menu items have now changed. So for example, you've got the overhead switch, which you wouldn't see within a switchgear.
And on this one, it's something that people have been talking about in a long time. So traditionally, when we trained people, we would always say you'd go, you have a single survey, a single workflow file for your switchboard. You then would have a secondary workflow and everything set up for your transformers and then your outdoor yards. But now with something like this, you can have all your separate workflows, but combine them into effectively one substation where you can flick through in all your categories. It's just a way of keeping all of that data together and combined, because one of the things we constantly preach when we're doing our trainings is you're not testing these assets in isolation, you're testing a combined network. So by keeping all the data together, you can be looking at a switchboard and you can go, well, I found PD, an internal void on the incomer cable. Well, now I'll quickly go to that transformer and look at the far end of that cable, and it's all within one substation, kind of one survey file. You're no longer having to jump around opening multiple files and juggling it. Everything is combined in one place and you can set it up really quite seamlessly.
Some great points, Thomas. Thank you. So now onto a topic we've all heard plenty about. We're excited to announce that the latest firmware update on the UltraTEV Plus includes powerful AI capabilities. For those familiar with the device, we've had ultrasonic phase plot classification for quite some time. These are algorithms that provide direct feedback to the users, indicating the likelihood that the signal is partial discharge or electrical noise. In the ultrasonic domain, this classification has proven to be highly reliable. However, achieving the same level of certainty in the TEV domain has historically been much more challenging. We've listened to your feedback, and we now know how useful ultrasonic PD algorithm has been to you and the benefits it can bring to TEV testing. To address this, over the past 18 months, we've been working to significantly improve TEV classification. Our team has collected and manually reviewed over 30,000 TEV samples, with each one carefully analyzed by our PD specialists. With each new analysis, the algorithm is refined into what we have today and will continue to get better as more data is scanned and uploaded to managed surveys.
And this one is kind of funny and a little bit sad in a way of it's been hours upon hours of looking at all that data that has been uploaded to managed survey and classifying it and the PD and the types of the PD, only for it to be summarized in two little letters that pop up on the screen that say PD or noise. So it's a huge amount of work in the background just to get what is a quite simplistic little bit of data.
Yeah.
And at the moment, it does indicate if it is PD or not. But the more data that we get and the more that we can refine this, the hopes is that we can take it further. As everyone knows with these types of AI algorithms, they're data driven. So if people do get more on board with the uploading of data to that Substation 360 and want to be involved in classifying and getting it really good to go, we've got some really high hopes for what we can do with that in the long run.
Yeah. So using this rich database, data set, we've trained our AI more accurately to recognize these TEV patterns. By dividing the data into training and test sets, we've achieved a recognition of 97%. While it's not perfect, this AI-powered feature is designed as a practical on-site support tool, delivering immediate, actionable insights without the need for extensive training or interpretation. As we continue to expand the dataset, the algorithm will become even more intelligent and precise, enabling faster and more partial discharge testing. So far, yes.
No, good.
Yeah. So far, we've talked about features that support on-site data capture. But what about the engineers in the room who appreciate diving into the finer details? Many of you would know that the UltraTEV Plus has always been capable of capturing data and displaying the information as waveforms and phase plots. Thomas briefly breached on this earlier in the presentation. So what's new is that we've enhanced the system to collect much more detailed waveform data and expanded on the device by introducing time frequency mapping. If you're not familiar with the term, TF mapping is a signal processing technique used to analyze transient, short-lived events and the change in the signals over time. These signals are often referred to as non-stationary signals. TF mapping is a way of visualizing these tiny electrical sparks by examining when they occur and the type of energy they produce. Those of you who work with motor diagnostics or other online systems may already be familiar with this approach. This type of feature is unique in the handheld testing world, making the UltraTEV Plus² the only handheld device on the market capable of capturing this level of diagnostic information. The tool provides a platform to separate overlapping events in a signal based on its shape and frequency of the waveform. This means we can more effectively distinguish between different PD sources and background noise, especially in a complex or noisy environments where traditional analysis may be a struggle. I'll show some example across the next couple of slides. So here on the left-hand side, we've got the x-axis, which is labeled by time, which is showing when the spark occurred. On the left-hand side of the y-axis, we've got the bandwidth or the frequency, which is sort of showing what the type of electrical sound, like what type the sound is made. So here we've got a illustration. We're circling this cluster here. What's that doing? That's separating that cluster from the TF map. It's changing the waveform based on that data selected, and it's also highlighting the phase plot, the relevant phase plot information. So here it looks like we've got quick sort of intermittent sparks, and yeah, it's the first example. I can see 3 sources in here. So in the second source selected, we can see that the phase plot has changed, the graph has changed, and we're highlighting this cluster here, which looks like a bit of a floating metal. Now here's the third and final PD source in this example is a vertical cluster of activity highlighted in the TF map. This pattern is typical for an internal void, and if it had been more active on both sides, you'd see 2 sort of vertical patterns here, slightly varied in time. TF mapping adds another powerful tool to your diagnostic toolkit, particularly for those challenging fault cases where noise obscures the true condition.
And this is something that people have been talking about for years upon years. Like whenever we do the training, we always talk about you have to be really careful about imported signals and noise sources and different bits and pieces like that. And people have always asked, is there a way to remove them from the plots and only focus on the PD? So now, if you do your full recordings, you can go back, you can look at that tdtesting map and look at all the different clusters, and you can just circle data points and you can see what you're looking at. So you can go through and say, well, what is this? And it works both ways. So on the phase plot itself, you can circle just one source and it will show you those data points on the TF map, and you can sit through and get down to just what you're worried about. We've done some really cool things in our trials where we look and we can see if you've got multiple PD sources on one board, but one's local and one's quite far away, you can even separate them because they've got those different characteristics in the TF map. And you can really break down your phase plots into the core elements. And it's really going to help people who are there going, well, I've got a noisy outdoor yard nearby, it's impinging. Those high-level contact noises aren't what I'm concerned about. I'm concerned about the PD, which is intermingled in the internal void with those. So it's a really good analysis tool, but it's available back in the office, not on the device itself.
So the final section I'd like to cover is the cable PD location tool. I'll be covering what it is, what you'll need, and how you can use it to identify PD and pinpoint its location during a cable length. So the cable PD location tool works using a modified variant of the time domain reflectometry, or TDR for short. TDR works by sending a short electrical pulse down a cable or a conductor and then measuring how and when that pulse is reflected back. Here is the image on the right. We can see that the UltraTEV Plus² has a HFCT attachment connected around a grounding strap of the HV cable. You can see that here. This type of test gets all the information required to find any PD locations along the cables. In the next slide, I'll provide an example of cable PD, but what we will see is that if the cable is perfect and properly terminated, we will not be able to see any pulse reflection. But if there is a fault, like a break, corrosion, water ingress, crushed insulation, or maybe some impedance mismatch, part of the signal reflects back to the source. By measuring the time it takes for the reflection to return and knowing the speed of signal travel in the cable, we can calculate the distance to the fault. So this is a great waveform captured by our service team out in the field and a perfect example to showcase this feature. Here we have a waveform generated by the Plus² and captured on site while testing cables using our HFCT accessory. It's a great example of cable PD. As you can see, a quick initial pulse here, a secondary pulse with slightly lower amplitude, and a third pulse at the end of the cable. When analyzing the data on a computer, we have tools that allow the waveform to be mapped and determine the PD location. This is done by inputting the propagation speed of the cable. This will change depending on what cable material you use. The default is 160 here. The cable length, in this case, it's 600 meters. And then by selecting on each one of these colored boxes here, we've got TO. TO is the initial pulse. You put the marker just as the pulse starts to increase. T1 is your secondary pulse. And then T2 is automatically generated by your cable length. However, you can manually select that too. The results of that is that you get a discharge location. In this case, it's 72.1, which equates to approximately 170 meters down the cable is your PD source. And
And the really important thing with this to note is it's not necessarily new information nor groundbreaking, but it's the first time that we've actually been able to implement this onto the Plus². So previously, before we did a lot of the optimization, a lot of the things, we only used to capture 50 waveforms, which you could look at and you could do this manually, but there wasn't often enough data to do it. If you wanted to do that really in-depth cable testing, you used one of our other products called the cable data collector. However, as we've really put a lot of work into this and we're capturing more data at a quicker rate, nowadays you're actually capturing up to 500 waveforms per test. So you can go through those individually, you can do this full testing and functionality and location, all with the Plus² that you've been using all along.
Yeah. Okay. For those of you who don't have a Substation 360 account, we'll give you a moment to scan the QR code here. This will take you to a page which you can create one. And then I'll pass you back to Thomas to discuss future plans for the development of the device.
Thank you. I'm just going to pull up our Q&A because we've seen a couple of questions come through, which we might have a chat about. So yes, one of the big ones, we've got things here talking about, will this work with everything? And yes, it is free. This is live now and you can do it. It will work on previous versions and different things like that. We've got a whole bunch come through here. Do we need... You should, one, just talking about all of the different sensors and should you do every time? Yes, I do think you do. We haven't really changed our stance on that with all the new sensor technology. You should always be doing at least TEV and ultrasonic testing every single time. And it's always there and different defects type can do it. At the moment, I use things like the VPIS as a complementary tool to assist and to simplify, but it is still rather new, and the TEV and ultrasonic are still the bread and butter of this type of testing. One here which talks about a quite difficult problem, and it's if you've got one of those cables that's got multiple joints, it's got a mixture of paper lead and XLPE, and does it kind of remove some of the accuracy of the cable fault, the location? And the answer is yes. Because you're using one set propagation speed, it will start to become a little bit less accurate the more joints you have and the different cable types. So you're looking at getting within a percentage quite close. The reality is, since most of your faults and your PD sources are likely to occur within joints or terminations, a lot of the time when you're doing this testing, you're comparing that data against your cable diagrams and you are rounding a little bit towards the closest joint. And it's just, you do have to do a little bit of leeway, a little bit of an engineering judgment in order to make sure you're looking at the right things. No, one of the good ones that just came through of can you update these for previous records? And not easily. We've tried to do it and back doing the things, it's really quite complicated. It depends on the version, it depends on a lot of different things to get that TF mapping working on historic readings, but a lot of them weren't capturing enough data. One of the biggest updates for this is in the background, and it's the amount of data we are capturing to generate those plots. So the reality is if you do have something and you want to look back of what it looked like on previous results, you need to go out and take it with the new firmware. Trust us, that has been a pain point because I've got so many good scenarios I would love to have it work on, but it's been a little bit of, we just haven't got the data in the previous ones.
Yeah.
So it was good to kind of chat about what we've released, and it's really good to notice that all of this is available and functional with the Plus² as it is. Over all our development of the Plus², we've only actually ever had 2 real separate hardware versions of the boards. The whole point of this device is it was built with the future in mind, and it's built with us to have the capabilities to put more and more functionality onto it. These updates will work with everything. They are freely available, and I recommend you give them a really good go. But what I want to look at now is what we're looking towards as we move to the future. And one of the biggest pain points when we talk to a lot of people is when it comes to ultrasonic testing. People tend to love TEV testing because it's a standardized test point and it's quite simple. People love the VPIS testing because it's you go, you put the ports in these 3 locations, and then you move to the next panel. Ultrasonic testing requires a little bit more understanding about your assets and the design of the switchboard. You need to know what your air gaps are. You need to know when to test. You need to know when to use the flexible sensor or the contact probe. And all of that is very much learnable. We train people on it every week, but it's always become a bit of a contentious point on, well, how do we trend it? How do we make sure that between multiple tests, we are getting consistent and accurate data? And how can we guarantee that we're getting a good air path and we are checking that anything's going wrong? As a counter to that, we're developing a new product, and we're calling it the UltraBolt, which is well and truly following our literal naming convention. But it's an ultrasonic sensor built into a bolt where the hex of the bolt sticking out of the gear is your connection point to the +2. And you can see just on the inside here, the little bit of the ultrasonic sensor sticking out. So the goal of these is they can be put into a board, they can stay in a board, and they allow you to go along. You have a guaranteed air path because the sensor is within the chamber. You can hook on the outside and you can get consistent data coming back to you repeatedly. It's not thinking, you can do it. Where this becomes really good is if you pair it with the managed surveys and the guided mode. So you can go through now and say, right, we want to go to this site. We know we've got bolts on every cable box or every CT chamber, and you can program that in that you want to go, take that data, and you can record it and you can trend it because you're getting the exact same data point occurring every single time. You know you're not getting any interference, you're not worrying about not having a set air path. You're not worrying about one tester holding the microphone a little bit further back for the trending. It's a really good bit of kit that I'm really excited about because I think it's going to make people's processes and their testing far more accurate. Right now, we are actually doing trials. We've got a number of trials going on in Australia. We know it works. It's an ultrasonic sensor. We guarantee you'll pick up the sources. What we are looking at to figure out is what shapes and what measurements of bolts are the most applicable. So we're working with companies to do that. You should have a little poll pop up any moment where you can see where we're just asking if you think this could be applicable to your network. Yes, definitely. Skewing my own poll there. But this is what you can see right here. So this is what it will look like on the outside of the switchgear, just that hex bolt popping out. We've then got a new accessory lead, which will plug into the +2, magnetically attach over that bolt, pick up the signals and allow you to read the ultrasonic signals from within the chamber. And I really do think this is something that could be quite fun out in the field, and we could get some really good data coming back. The kind of overall goal of this is we're really focused to continuous development. And that development isn't just initiatives pushing forward, kind of breaking new ground with the new sensors, but it's also how can we make this device work for you and work in your network. And again, I can't thank people enough for all the feedback that they have given. And hopefully once you all get your hands on this latest firmware update, you can have a use and you can let us know what is or isn't working. It's always hard for us. We use this device every day. So it's quite hard to know what
it quite well
for new people isn't or isn't working. Yeah. The best part is it's all using the standardized +2 hardware. There's nothing new here. You don't need to do massive upgrades. It is inbuilt and it is free. And that's something we're really adamant about keeping for everyone. All of this was able to be done effectively, and especially the AI, through that end-to-end web integration. Having a full database of samples and signals allows us to do so much more and to do some really fun data analysis that I'm keen to see how far we can push it, because the better we can get with the AI, the simpler it'll make testing in the long run. If it's not getting there and it does need further analysis, that's when you can start to look at the T to F mapping, look at the cable fault location. You can do everything back in the office as well. But the simpler we can make this for the in-field testing, using the UltraBolt, using the guided mode, using the algorithms to give you your answers, it'll give everyone more accurate data. Other than that, thank you very much for coming and listening to us rant about PD for 45 to 50 minutes. It's been great to talk to you all. I hope you do get a chance to get your hands on this device. I hope you can use the new firmware, and I hope it makes your life easier in the long run. Thank you very much, everyone. Have a really good day.
Thanks, guys. Yeah.